Hello Internet, I'm Kaffee Apparat, you can also call me Robin, and welcome to Fun Project Monday on Friday. Yes, you have right, on Friday. Yes, what is this live stream about? This live stream is about designing an electronic device and electronic products with no retention. We build it for fun. We don't look at cost optimization, we don't look at deadlines, at least no bad ones. And we simply fool a little bit around and see what we can do. Yes. Why do I do this live and not in some hidden chamber? Yeah, why not do it live? Maybe I can learn something new through conversation, and I think it's fun making a transparent experience. One question to the chat is the audio right? Yeah, most probably it is. Okay, this live stream will be only a drawing live stream, so no big electronics. So we simply line out what we want to build, and then we will bring it into production. So let me change something here. And let's start. What do you want to build? Our goal is, which I defined, is to build an... Okay, now my pen is... Oh, my pen works. Great. Chat says audio is fine. And of course, some coffee. Makes everything better. Okay, we want to build some sort of LED controller, but not just some kind of LED controller. LED controllers were built thousands of times, nothing new. But I want to build it in a desktop format. So I will draw it up. We want to build some kind of... Oh, you can't see me. Wait a minute. So now you can see me. So we want to build some kind of desktop device. Something nice. So you can put it on a desktop, dial a bit around. We will only do it one time. But for the sake of the argument, we want to have some buttons, some dials on there, because everybody loves buttons, dials, and knobs. And some indicators. What kind of indicators? It's not really important at this point, but we want to do some basic outline of what our goals are. So we'll do some main goals. And for that we can take... What could we take as a main goal? We could say we want to drive 3 channels of RGB strips. What kind of strips is not really important at that point of time. We decide that later, but 3 channels of RGB strips. It should have some buttons and knobs, pretty obvious. That's the main goal. We want to design it EMC friendly. So we want to keep the option open that we sell such kind of device that we are able to ship it around the world. And for that, we need to take care that we don't produce too many electromagnetic disruptions. So we will try that. Although I'm not really, don't have a test gear, maybe I can organize something. So, EMC friendly. And last, we are in 2022. You can't build a device without a wireless interface, or such kind of device without wireless interface. That's not really up to task, so we want to have some connectivity. So that are our main goals. And to define such a device further, we need to take a look on what kind of connections it actually will have, because such kind of device will get some power input. It would need to have some processor, and it needs to give out some output. And depending on what kind of output we choose to desire, because there are different kinds of LED strips available, we will need to choose our different input parameters. Let's try it. Let's line it out. For example, okay. Let's define an output section. So we line everything out to make a transparent design process, to bring light to the work of an electronic engineer. So output, we have input. Of course, everybody would do such thing differently, but this format, I think it's good for a live stream. And we have some kind of processor. On the output, we would find such thing as indicator and indicator lights too. But we will first work with the LED strips. So we have some kind of LED strip output. For that, we need to check the different kinds of strips. We have, for example, 12-volt strips, 3-channel. I don't know if there are 4-channel strips, like with a white LED added. But I don't care about that kind. So 12-volt 3-channel strips, we have 5-volt 3-channel strips. So we get 3 signals for every color. And of course we have the 5-volt digital strips. The question is, do you want to use them? Of course, 5 volts could be a gimmick, and it could be interesting to build an, let's say, an device which operates on digital and analog strips. And with working with 5 volts is also a thing because of the voltage drops you get, or voltage drop at the high currents you get. So it would be the easiest to say we only use 12-volt strips. 12-volt strips are relatively easy to handle. The current is not that high, and it's really easy to drive them. 5-volt strips, of course, they're also easy to drive, but the current requirements, because of the low voltage, make it harder to work with them. So we actually want to focus on the 12-volt strips, but I think it would be interesting to build an output which supports both, for example. So we will do both, or at least thinking about both. So let's continue with the processor. Of course, there are, output, some indicator lights. And we could define what we want. Of course, and the output of the indicator lights is also connected with the input indicator lights. So both systems work in harmony. Not input indicator lights, of course, input buttons and dials. For that, we can think about having, of course, rotary encoders for the different colors, so RGB. Of course, I think that would be the obvious choice. Another obvious choice would be having only one rotary encoder and button changing through them, and another button changing through the channels. So we have different options here. We could say we have, first of all, one for the RGB control itself, 3 rotary encoders. Plus 1 button. Or we could use 1 rotary encoder and 1 button. That would be, cost-wise, way more efficient. But no, we don't need a button for that, no. And 1 rotary encoder. Plus button. That could be a really good option. And together with that, and of course, maybe you get an, and with option 2, we would definitely need an indicator light, which kind of color we're changing. That would be good. Of course, you could see it, but if you have set up your color just as you like it, and then you need to change through, that is kind of exhausting. For option 2, we would need to design some indicator lights too. And then if we continue further on the input side, what would we need extra? Definitely buttons to change the channels. We could use only 1 button and indicator lights, or different or 3 buttons for every channel. I think the easiest would be having, yeah, we can build a very clean device. That would be very nice, having only a few buttons, a few controllers, and then working with it. That would be, yeah, that would be good, I think. But keep both options in mind. So extra for channels. I'm going to write that up. For channels. Or channel switching. We would either need, first of all, 1 rotary encoder. No, 1 button. Or 3 buttons, depending on the kind of device you want to build. Plus, as indicator lights for channel switching. We could use, I think in both cases, we could use 3 LEDs. Yeah, that's good. 3 LEDs. 3 indicator lights. So you would need to change so or so. Then would you need something else for control? Maybe having option to change from wireless to manual control. Yeah, that could be a button, or yeah, that could be a button. To do something if a device goes haywire. We would need 1 button. And we would need 1 indicator light. And 1 indicator light. Or 2. 2 indicator lights has more style. Because you want to have, you want to see if it's on wireless or in automatic mode, or you're controlling it manually. So 2 indicator lights. So, of course, another option or another problem is input power. Now that we have more or less, or we could use 1 extra. Yeah, we can add 1 extra. With every one of these cheap controllers you can buy at AliExpress, eBay, or whatever, you have fading, you have control, you have some effects in it. We could add one more button for switching through effects and a few indicator lights for saying what kind of effects. We will add that. That would be nice. Some heartbeat or some fading. Yeah. We're not in German, we write with C. Effect, one button. And of course, with wireless manual change, let's say we have only... No, we don't need that here. No, we don't. So that you know, that's more or less improvised. Of course, I've put some thought into everything we do here before, but most of it I never thought before. So it's more or less a journey we do together. And that's really interesting. So, power. Of course, the next thing to consider is the input power. It depends on the voltage we want to feed into the device. The problem with, or the gain with a higher voltage is the higher the input voltage, the thinner the input cable can be. For example, if we have our strips that all run out of 12 volts, all the power that goes, or all the amps that go into the strips must come from the input cable. That is not always desirable. But we will do some calculations, some ballpark calculations, what we could do. One thing that we can rule out. So what would be some options? Some options would be 5 volts, that's great. Something around 12 volts or 15 volts. Why I write 15 volts has another reason. And of course we have 24/48 volts, which is relatively, a voltage range which is likable through norms. Here in Europe, you have some norms regarding the safety of devices. And as long as you stay under 50 volts DC, you're pretty set with not having too much consideration. And of course, we could use mains power, so 230 volts. But that's something I don't want to do, quite plainly. I've never designed a 230 volt supply, at least not switching one. So I would definitely not do this. And for simplicity, we want to 5 volt digital strips. We could do them, yes, but we want to keep that project at some point simple too. Next, a processor. Of course, there are different options for processing power. We could use some Arduino AVR and ESP32, or even a PSOC device from Cypress, or PSOC 4 or 5. And if we're really honest, for today, for such kind of device, you use an ESP. It's the most simple one. It is easy to develop. You can use the Arduino IDE. There is tons of documentation. And of course, with an AVR, you need to add some sort of wireless circuitry first. That is, of course, more work. And these PSOC devices, they normally only come with Bluetooth. And if you have the decision between Bluetooth and Wi-Fi, yeah, you most certainly want to use Wi-Fi. It's cooler. So I think that's a choice we can pretty much rule out. We'll use an ESP. That's not the cheapest option, but yeah, a good option. Next thing we need to consider is connectors. That's the best. That's the most rewarding discussion. It's so rewarding that I don't want to do it now. Because in the price range, or to make it not extra expensive, you would either stay with normal or these mass-produced aviation aviation grade or aviation, what do you call it, connectors. They are pretty cheap on eBay. You could also use something like mini XLR or the DIN connectors, but that is a very that's a very special discussion that I don't think we want to do now, because for that we need to do researching on the sites and check between the different connectors available. And I think the easiest would be to not think about it now, but to specify the looks of our device more. For example, now we at least made some general outlines. So we know that we will do 1 to 3 knobs. Yeah, that's good. We will do some buttons. So most probably, yeah, for effects we can use 1 to 3 buttons. Like if maybe they're not that expensive and they look good. And if they look good, we put some more on them, of course. Some buttons, yes. So we can conclude that we use 1 to 3 knobs. That we will use 3. Let's take a look. 1, 3 buttons. 1, 3. 3 to 6 buttons. Or push buttons. We'll use 1 ESP connector or 1 ESP processor. We would have 3 circular connectors on the back. Oh, and which kind of power to use in the end? It's yeah. It depends. We can specify that more correctly. So we certainly won't use 5 volts and maybe even not use 12 volts. Because by using 15 volts, we can still use a DC-DC converter in the middle. And because most DC-DC converters have a short circuit detection. So if we short our LED strips or do some dumb things, their outputs are protected. So it would be a very good idea to have a 15 to 12 volts or 24, 48 volt DC-DC converter to 12 volt DC-DC converter. So we can make things more easier for us. Let's take a look. So I have one kind of power connector, which exactly we will use, that's not really important currently. And we will have, let's take a look, 3 output circular connectors, or 3 output connectors. And we most probably have 2 for the wireless manual, or the effects. We will have some indicator lights too. Let's say 3. We will be so we have 3 indicator lights. Let's take a look. Do we have more? Um, 3, 2, 5. So we have up to 5. We have up to 8 indicator lights. Let's see, what do we write down? Everything else? Yeah. That's more or less everything we can add to the kind of basic outline. Of course, we can even start conceptualizing how we will arrange them. We could do this now because that allows us to decide after we get a rough estimation how our products, what interfaces our product will have, we can do a sketch, a real sketch, and maybe even a more detailed sketch, deciding how we build our product. So, what I already have specified is that we want to do some desk mount, not desk mount, desk placed device. So we'll have a device which will have look like this from the front, and from the side it will look somehow like this. And at that point, front side, and of course from the back we will have some even space. For everyone complaining that aren't the right views on a device, that's not important. It's a sketch how we want to do things. What would most probably happen is that we will have a few kinds of connectors at the back. So, for example, we could have one power connector and 3 LED channel connectors at the back. Well, good. What kind is, we can still decide on that if we estimate how big we want to build it, but yeah, power connectors. And we'll have 3 LED connectors. What is already be estimated is that it is a portable device, and that's good that it's portable. Something nice you can take with you. From the front, we'd most probably have following arrangements. We go from a worst case, so we'll have all 6 buttons and all 8 indicator lights. So we would have at the left, for example, a button array that would look like this. We would have the 3 knobs on the right side, and the indicator lights placed somehow and in some shape. It doesn't matter which one. So buttons, knobs, and indicator lights, indicators. What kind of shape they have, that's not really important, because with modern, or if really long modern and cheap PCB prices, we can build some very nice labeled indicators by having, for example, 2 layers of PCB, or having multiple, or using backfiring LEDs. There's a lot of possibility these days, and we will use a lot of this. And from the side, it would be not that exciting. We would see the knobs, yes, and that's it. In such a device, we most probably won't need any ventilation, but we could do some calculations regarding that later. That would be interesting. I'm looking at the time. We have 40 minutes live. I think I will do some more if I think of something we could do. No, I think that's good start for today. We more or less conceptualized and have an image of what we want to build. So at this point, we will stop the stream, and next time we'll think about how we implement stuff. We will draw some sketches, what kind of height we should use. Thank you, Sebastian. We'll see what kind of construction techniques we'll use with the buttons, what kind of buttons. Maybe we'll do some research. That would be great. And yeah, thank you for watching. See you soon.